In 1820, he became a professor at the University of Turin, but was involved in a political uprising and consequently lost his position in the university. However, sometime later in 1833, Avogadro was later recalled at the university in Turin and served another 20 more years. Avogadro also had a wife. He was also known as a member of the Royal Superior Council on Public Instruction, a city hall with Avogadro in the middle. He later died on the 9th of July at 1856 in Turin, Italy, the same place where he was born. Although he passed away 150 years ago, his legacy remains to this day. His greatest contribution for the fields of chemistry is his molecular theory, which now bears his name.
Avogadro's law talks about the relationship between the amount of the gas sample and the volume of that gas sample. It describes how equal volumes of all gases contain the same number of molecules under constant levels of pressure and temperature. In other words, it states that the amount and volume of gases will be proportional as long as the temperature and pressure will be held the same and constant. When solving mathematical problems with Avogadro's law, the formula used is N1 over V1 is equal to N2 over V2, where the N1 is the initial amount of gas and V1 is its initial volume, while the N2 and V2 are the final amount and volume of the gas respectively. This equation is used to determine the changes in the given variable properties of the gas. Let us try some given problems. Number 1. 5 liters of a gas is known to contain 0.965 moles of gas. If the amount of gas is increased to 1.80 moles, what will be its new volume? Before we solve this problem, things can get much easier if you write down first the given values. So, in this problem, the initial volume of the gas is 5 liters, and the initial amount of the gas is 0.965 moles, while the final amount of gas is at 1.80 moles. And apparently, we are looking for the volume after the change has occurred. In solving this problem, all we have to do is to simply substitute, then cross-multiply them, and this gives us to 0.965 over 5 is equal to 1.80 over x. So 5 is to be multiplied by 1.80 and 0.965 is to be multiplied by x. 5 times 1.80 gives us 9, while the other side gives us 0.965x. Then, we do the cancellation in order to isolate x. Divide both sides by 0.965, then we will end up at 9.33 equals x. Therefore, if we raise the moles from 0.965 to 1.80, then the volume will also go up from 5 liters to 9.33 liters. In the second problem, a gas storage contains 50 grams of nitrogen, which occupies 13 liters of volume. How much gas will be added if we put another 2 liters of volume? Now, whenever we solve problems involving ideal gases, the amount of gas has to be expressed only in moles. However, in the case of this problem, the amount of gas is written in grams. In order to determine how many moles are there in 50 grams, we have to divide this amount by its molecular mass, and nitrogen has a molecular mass of 14.01. So 50 divided by 14.01 gives us 3.57 moles of nitrogen. Now that we got the moles of 50 grams of nitrogen, all we have to do is to substitute these values in the formula. So it should be written as 3.57 over 13 is equals to x over 15. As you may notice, the second volume is written as 15 Because it is stated in the problem that 2 liters will be added from the first volume in order to get the second one. To get things finished, the same process goes here as we did in the first problem. Cross multiply 3.57 times 15 and 13 times x. This leads us to 53.55 is equals to 13x. Afterwards, divide both sides by 13 to isolate the x. This gives us x is equals to 4.12. Therefore, 4.12 moles of nitrogen will be added to the storage if the volume is raised to 15 liters. Avogadro's law may sound complex, but this is actually evident in so many things that we see. This includes inflated balloon, vehicle tires, basketball, and even in our normal breathing. All of these examples involve the directly proportional relationship between the volume and amount of a particular gas sample. This ends our video. Thank you.